Welcome back in our sorting station, and in this video we will see how we can simulate sensors. So we will start here with the first sensor of the station. It's a sensor here that will detect that a workpiece is at the start of the conveyor. So to do that, we will simulate the sensor with a block and a collision sensor. So we will first create a block. So I will create it and then you will be able to see it. And I will hide the workpiece so you can see it. Okay, so we created this block and we will create a collision sensor on this block. So with that, when the workpiece who has already a collision body, when the collision body of the workpiece will cross this collision sensor, the value of this collision sensor will change. It will be triggered from false to true. So I choose here my collision sensor and I just select it. Collision sensor at entry. Collision shape, it's the same, and for the collision body we have different shape that we can choose. Okay. And what I like to do too, so here you can find your path navigator or block. I like to change its color. And I set a specific color so we know it's a sensor. So I will set it back. And now if I press play, my collision sensor is here. Okay, for the moment it's false. And if I bring a workpiece, now we see the value is true. And if I start the belt, now the workpiece is not on the sensor anymore and the value is back to false. And what we can do now is create a signal that will connect with the PLC. In this case, for input, we can connect it with a runtime parameter. We will choose this. I choose my collision sensor, and directly by default, it will set it as an output. It's an output for MCD, but an input for the PLC. And I just have to give it a name. So now this signal can be sent to the PLC. And of course, will have more than one sensor. I will have another sensor here before the stopper to detect the color of the workpiece, and I will have another sensor at the exit of the conveyor to detect that the workpiece is out of the conveyor in one of the slides. So I will create those two blocks. Of course, I already know where to set them. Here is one for the color sensor, and here is the one for the detection of the workpiece on the slide. I will change the color. The next one, I change the color. Okay. And then I will assign them collision sensor. So it's the same. I select my block and I set a collision sensor color for this one. Next one, collision sensor at slide. Okay. And I can also directly create the signals. So I connect with runtime parameter, color, signal, color, connect with runtime parameter, collision sensor at slide, signal at slide. Okay. Now if I take my runtime parameter, at entry at slide color, we can remove this one. So at entry at slide color, they are all false. And ring our piece. At entry is true. I start the conveyor. At entry is false and color is true. Detected. I will retract my stopper. Color is false, and let's check at slide. Okay, so we've seen that the value was true when it crossed the sensor. But now you are probably wondering how we will detect the colors. And to show you that, I already imported another workpiece, a blue one. So if I go in my path navigator, I see the blue one here. We can see it if I hide the black one. So we have another one here. I already created the rigid bodies and the object source that goes with it. And what we're going to do to detect the color is here to set collision categories. So we will say, for example, that the black workpiece is a collision category 1 and the blue is a collision category 2. And our collision sensor here will only detect the category 2. So how to do that? I come in the definition of my collision body for the black workpiece, and in the category I will set the number 1. For my blue workpiece I will set the category 2, and for my collision sensor, I will set the category 2. Okay. So now, if I launch the simulation, I set a black workpiece. So here color is full, it's normal, we are not in the detecting range. I will start the belt, and we can see that the black workpiece is in the detecting range of the color sensor, but the values stay false because the category 2 only detects category 2 or category 0 and not the category 1. So now we move it, we will make appear a blue workpiece, and we can see that the color detection is true in this case. We move the stopper and it's back false. And here we can see a small issues. They are both not colliding. Why? Because one is collision category 1, the other one is collision category 0. So basically there is no collision between them. So we will fix that by just adding another collision. So we define a collision body, we'll say only the base, we'll say category 0. So collision body, blue workpiece, base. And we will do the same for the black. Still category 0, okay. And so now, if I relaunch the simulation, I set a black one, I start the belt, I move the stopper, I set a blue one. And now they are colliding each other, but still are being detected a different color with our color sensor. Okay, now another type of sensor that we will need is a limit switch. Limit switch that will trigger when the position of our separators are retracted or extended. To do this, we will come in the sensor section and we will create a limit switch. Then from that menu, we will select the position control. So here we will take for the separator 1 position control. We will take the position as parameter and we will enable limits. So we will first start with the lower limit. We will set 1 degree. This means that under 1 degree, it will trigger the signal. So limit switch, separator 1 retracted. Okay, and we will do the same things for the extended one. So we take the position, upper limit, and we will say that above 45 degrees we will be extended. So limit switch, separator 1 extended. Okay, so now we can link those two limit switch with signals. So same will apply that with the collision sensor. So connect with runtime parameters. We select in our sensor actuator list our two limit switch. So we will start with the extended. So separator 1 extended. Okay, and the next one for the retracted. Okay. Now if I launch the simulation, I will take those signals. So for the moment, the retracted is true and the extended is false. If I activate my separator, we can see that now the retracted is false and the extended is true. So that's it for this video, and thank you for your attention.